Greetings, everybody. This is Christopher Messina coming at you from the Messy Time Studios, broadcasting as ever from the beaches of the last free state in America, Florida. Joining me today, not in Florida, sadly, from more northern state that is less free, but we're not going to get into arguments about that. It's Anna Metke, who is the CEO of Space Resources Technologies, and she is going to tell us all about why space is really dirty. And welcome to the show. How are you?
Oh, great. Always good to see you, Christopher.
Always a joy. So let's dive right in. Space is dirty, which will be news to those of us who only got through sort of astronomy 101 in college and found out there's pretty much nothing in space. So it's delightful to find out that when you get up there in the massive vacuum, the vacuum itself is unclean. Why don't you correct me on where I got that wrong?
Right. So the surface of every other planetary body is really actually dirty, especially when we look at the moon and when we look at Mars. You know, the moon doesn't have an atmosphere, so it's constantly being hit with what we call micrometeoric bombardments, and there's just flying all over the place. And this is becoming a really interesting challenge for us, especially as we increase our time in space and increase lunar operations.
Yep. So it's I'm being slightly facetious because I'm the president of a lunar mining company. So I'm hearing all sorts of stuff from the engineers about not only is space dirty, but space is sharp, which is something that people don't think about because you get used to wind and rain and erosion here on planet Earth. There is none. So if crystals form on the surface of the moon, there's nothing to keep them from being insanely sharp for billions of years. Is that part of what your company does? Is provide source material for people to test out robotics, things like that?
Right. Yeah. So what we do is we actually replicate the dust on Moon, Mars, and asteroids for space hardware testing. So, when NASA or lunar hardware companies are getting ready for their journey for the moon, they need to test that hardware in the most accurate simulant possible. So that way they can make sure that their hardware is going to survive on the lunar surface. And it's an interesting process.
It is, and inquiring minds would wonder how on earth does one go into the business of providing lunar regolith simulant to robotics companies?
Right. So during my undergrad, I had the pleasure of working at a microgravity research lab at the University of Central Florida. And on day one, I'm getting a tour from the lab manager at the time, and he's showing me these different microgravity experiments that we're doing. And we were really studying the formation of planets in our solar system. And what we were doing was we were running these tests on drop towers. So if you're not familiar with what a drop tower is, it's basically just a big tower and you drop something from the top, and while it's falling, it's experiencing microgravity. So you get to do a very short, quick microgravity experiment.
Hmm.
And what we were doing at the time was we were taking glass marble beads and launching them at each other to see how do they repel from each other, how do they stick to each other, and we were using that data to create simulations of how our solar system was formed.
Yeah. So am
All
I
of
right
this,
in believing, and this could be just my Italian prejudice, am I right that Leonardo da Vinci created the first drop tower, or is that just folklore?
that is a good question. I'm going to try to find out because that's a really fun fact.
Because all those old cartoons of the leaning tower of Pisa is perfect because it's already leaning, right? Excellent. And so what are the challenges and limitations, or what are the challenges to creating near lunar conditions, at least soil wise, when you're here on Earth? How close to reality do you get so that people are comfortable that when they're testing their robotic systems in your test simulant, it's actually pretty good as a proxy for what's up there.
Right. So what we do is we have a lot of data about the lunar environment. For example, we brought back samples. We're doing different kinds of spectroscopy techniques to identify what minerals, chemicals, and materials do we have up there. So what we basically do is we reverse engineer it using terrestrial materials. And what we focus on replicating is the mineralogy, the physical properties, and the chemical properties.
Hmm.
And like we talked about before, the lunar environment is very unique because there is no atmosphere and it's constantly being hit with these micrometeoric bombardments. And every time that happens, the regolith will melt from the energy of the impact. And that's just happening over and over and over
Hmm.
again. And like you said, the lunar surface is very sharp and glassy. So it's very fluffy and very abrasive at the same time. So what we're able to do is
So many jokes occur to me that I'm just going to let slide. Sorry,
um,
carry on.
yeah. So what we're able to do is we're able to mimic most of those properties. And we do that, like I mentioned, by reverse engineering it. So we look at different mineralogical deposits on Earth and we look at their chemistry profile. And then we say which ones are the closest match that we can find. And then in addition to that, we also want to make sure that we're mimicking the shape and the size of the different particles. So we have to use specific mineral processing techniques to really get the jagged shape. And then we also use different sieving methods to make sure that our final product is also matches the particle size distribution of the regolith that we find on the moon. So it's very, very expensive, fancy dirt. It's affordable enough where you can go and put it in your shopping cart and buy it online if you want to do a science fair project.
Right.
But it's an extensive process because you really want to match and capture all those different physical and chemical attributes.
That's fascinating. So obviously, as with any industrial process, the material you start with, the closer it is already to the final state, the easier it is for you. Right. So that was your comment about finding the right deposit on Earth that's analogous. Now, and I would, it's a question. I'm not entirely sure. For our viewers, what's the kind of aggregate amount of material that was brought back from the moon that we use for such analysis, and what's the sense of how representative that is of the lunar surface, or is it really there's just we're going to have to take many more samples over time to really get a better picture?
Yeah, well, we're definitely going to have to take more samples over time to get a bigger picture. But we had a few Apollo missions that brought back some samples directly, and then we also had, for example, a Chinese rover recently that collected samples and brought those back to Earth from the far side of the moon. And I think in total we've brought back about 300 tons or so quite a bit.
Yeah, quite a bit.
300 kilograms, so quite a bit. But if you can imagine, you want to test like a rover wheel. A rover wheel is, quite big in size. That's not really even going to be enough to test that, and that's if you had access to all of it. And during the Apollo missions, we mostly landed in the Mare regions. That's, if you can imagine what the moon looks like, you can see like the darker regions on the moon and then the lighter regions on the moon. The darker regions are the lunar Mare. That's where most of the Apollo missions went. We did go to a highlands region as well. And as you may know, the Artemis missions are focused on going to the highlands regions and specifically the lunar South Pole because, and you, Christopher, you can tell us probably a little bit about that.
Well, we're within the limits of the veil of corporate secrecy because I am a greedy capitalist pig, not a scientist. So which is fair. The world needs all types. Because what we're doing at Magna Petra is mining helium-3 on the lunar surface. One of the greatest things I remember doing as an experiment when I was younger was my father is an engineer, and a lot of the guys he worked with, the women he worked with, were all engineers. Half of them were space dorks, and one of them told me, I never forget this. He's like, just take a kind of big pan, paint it white on the surface, fill it with an inch of water, and just put it outside, without any trees or anything above, and just leave it there for a couple of days. His point being, and then take a magnet later and run through it, right? And picked up all these iron filings. And so I forget the number, something crazy like 2 tons of material falls on Earth every day. And it gets incinerated, but it's all tiny little bits of sand. You wouldn't even notice it. So we've got 2 tons of iron falling on the planet every day. I always remembered that. So when I heard the premise of what we're doing at Magna Petra, which is 4.3 billion years, or 5,700, depending on who you believe, that the sun has been spewing helium-3, the neutronic isotope, out into space, and it lands on the moon, and it bounces off the Earth's magnetosphere. So I am just fascinated by the science, first off. and it's very similar to how we look for mineral deposits on Earth. Same kind of process. Where do you think it's likely there's more of it? Why is there more of it? You mentioned, tiny little asteroids and bigger asteroids hitting the lunar surface, and how large they are depends how much energy they bring and how hot it hit, and what does that mean? It's absolutely fascinating. I mean, at the end of the day, I want to find the most material for the cheapest cost and bring it back, but
Yeah.
doesn't mean the science isn't interesting.
Right, exactly. Yeah.
And what is your sense? Because you've been arguably studying this a lot more closely than I have for a lot longer. Is I don't know how to ask the question? I guess, like, are you like 95% accurate with the material you provide? Is it 88%? Can you know? What are the metrics by which you judge your production, and what are the metrics by which industry judges that production? And do you think those two are aligned?
Yeah, so there's different ways we can kind of look at it. And from a general perspective, we can say that most of our materials match their target by up to 99%. And there are some interesting aspects of the moon that do make it harder for us to replicate certain things. So we can kind of talk a little bit about what's more difficult. So, like I mentioned before, the moon is very glassy. So what we can do is we can try to mimic that too by blending all these minerals together in the right proportions and then melting all of them and then processing them all over again to kind of match that level of fidelity as well.
Right.
But
So
also,
you basically make glass out of the constituent minerals that match the lunar surface samples, fraction them
exactly.
again, grow crystals off them, and that should get pretty close to what's on the surface.
Exactly.
Hmm.
But when those processes happen to the moon, it's not as simple as just melting something on Earth because different types of elements can get trapped into that process. So, there's different values of certain attributes of that make it harder to mimic. But on a general scale, we're able to get incredibly, incredibly close. And especially when it comes to, mimicking what traversing over that terrain is going to look like, for example, for a rover,
Hmm.
that's going to be a really good match, and you're going to get really good experiment results from that.
Hmm. I had a fascinating conversation with a lunar scientist, the other day, who was describing. I hadn't really thought about it. Right? Is when anything lands on the moon, whether it's a rover, whether it's meteorite, whatever it is, um, dust plumes fly up, but because there's no atmosphere, they act very differently than they do on Earth, where air resistance causes things to curl and causes things to settle, and gravity is about 1/8, so that doesn't have much of an impact. Is there sort of general rule of thumb for kind of weight or size of energy impacted on the lunar surface and the ejection fraction of material that's just lost to space entirely? Does that matter in terms of how you do your composition analysis, or is it really just, well, some of it's going to go, some of it's not, and that's just life?
Yeah, when we do plume testing, we need to take all those things into account, and it becomes really interesting to try to study that on Earth. And like you said, there are some really high-profile scientists working on these problems because, from what I understand, especially at that point, you need to have the right materials that you're testing with, but you also need to make sure you're testing in the right environments. Like it needs to be in vacuum and things like that. So that
Right.
changes the game. And I know that this is a huge area of interest right now because when we're talking about how we're claiming geopolitical space on the lunar surface, this is kind of how we're playing that game right now. Where if I land something on the moon, and let's say I have some sensitive equipment on there, I have some cameras, etc. So I can say as the US, nobody else can land within however many miles of this rover because it has a sensitive equipment. And of course, the ejecta from the landing will cause damage to my
Yeah.
equipment.
It's
So
like
this is
vicious
kind of
sandblasting. It's horrible, right?
right. So this is kind of how we're claiming territory on the moon these days.
Right. Which is going to, if human behavior is any guide, is going to replicate the colonial battles of the 16th through the 19th centuries across the oceans. Right. That's my
Exactly.
city. Is it now? I've got 3 ships with bigger guns. I don't think it's your city anymore. I mean,
Right.
call me crazy. So
Yeah.
we're gearing up for that. I had wonderful moment at a space symposium where
Mm-hmm.
many folks are coming together for this, and I think those who've been kind of in the space industry are now aghast at all these kind of rapacious capitalists who've shown up because we found out we can make money. And we bring a very different mood to the room. Big bunch of big meeting, a lot of lawyer types, a lot of folks who think the UN is useful instead of evil, like all that kind of stuff that distinguishes us from the nicer community. And they were talking about treaties that were signed, and on and on and on. And I just laughed, and the moderator kind of asked, like, "What's so funny?" I said, "I'm building the Dutch East Indies Company in space, like half warship, half robotics. Like that's the Chinese, our only competitor, presumably are going to figure out what the corsairs, privateers, and pirates of an earlier age figured out, which is it's so much easier to steal the gold out of the ship once you've gone and found it." And I'm sure there's going to be a lot of that. So it's fascinating to plan ahead, thinking about things like, there's no police force to call. There's no law on the surface of the moon. Lots of happy-go-lucky people think that signing treaties down here means something. It means zero. So it's going to be. I'm delighted to be alive at this point in time, and I hope to be here for a while longer to watch it unfold. But reading a lot of the early science fiction writers going back 100 years or more, I think the ones that mainly talked about, war disputes between the lunar colonies and Earth, the rest, I think they got it absolutely right. And the sooner anyone feels a piece of ownership on the moon, it's just going to get vicious fast. And but it was just that particular issue I hadn't thought about, because even when you look at, what was that great movie with Matt Damon on Mars? But
The Martian, I think.
The Martian, right? The Martian. Is that, in reality, when anything lands, you better get your head down, or you better hope it lands in a bowl or a crater, so that the sand blast, because when that sand goes out and that dirt goes out, it's going out at hundreds of kilometers a minute.
Right.
And what are you going to build structures up there to protect against that? Like, it's going to be a very complicated process. There's going to be a lot of mistakes and a lot of errors, I'm sure, along the way, but a lot of demand for your material, because people are going to start buying it and shooting it out of blast cannons at the rovers they built, which is going to be awesome fun. Right. It's going to be a lot of fun. Is anyone doing that yet, or did I just find a new business model?
I think there are some people doing that. People do the regolith blast testing as part of their equipment testing and things like that. And it's interesting because I do think you bring up a really good point, because now, as we heard with the Ignition Initiative from NASA, we're changing, our priorities from kind of exploration to developing lunar base and having ongoing lunar operations, which means we have in-space assets. And we're also moving into a really interesting time with the International Space Station getting ready to retire and moving to private companies having space stations in orbit. So what we're really doing is we're really maximizing the commercial value of the space ecosystem when it's in orbit and on the moon. And I'm really curious to see how, what international relationships are going to look like for that. And again, who is it? Who's going to be protecting those assets? Is it Space Force? Who is it?
Well, it's funny because I live just down the road from the major Space Force headquarters, and had a chat with the commandant a little while ago. I said, much like the British Navy of the 1700s, your job is to protect my stuff. It's like, yeah, I get that. but it's absolutely true. So right now, Space Force, all the depredations of Hollywood aside, because who could resist, right? The Space Force budget, I think, is like 1.5% of all military spending. I predict within 10 years it's going to be 50%,
right?
If not more. I mean, there's a huge amount of considerations that go in. I appreciate the AFRICOM and CENTCOM commander who was, leading the effort to spank Iran finally after 47 years. And he specifically gave a shout out to Space Force for, all of their assistance, which comes down to a lot of positioning and guidance and satellites and all that sort of stuff. Um, so it is going to be vastly more important. And it's very funny when I speak to folks outside of Florida, right? For us, this is the hometown industry. Like, I watch the rockets grow up from my backyard. So
Mhm.
there's no mystery here. And I don't think most Americans have a sense of the launch cadence. I mean, SpaceX put up 168 rockets last year from, I think, 43 years prior. Like, the cadence is picking up. And from our point of view, our entire goal, to us, SpaceX and others like them are like the railroads were to the oil barons. And I make that analogy deliberately, right? Without
Mhm.
an ability to get up and back and a transport system that's reliable, everything we do is for naught. And that's
Right.
fine. And so the more, I wish them all success. SpaceX is doing well. Blue Origin is lagging a bit behind. And there are a few others coming into space. But, let 1,000 truckers bloom. I want competition in the space. I want my freight rates to come down. And they're getting there. But do you have any kind of final thoughts for, students who are interested, schools who are interested in maybe, using your material for robotics clubs? Like, what is the advice you give out to younger people when they're thinking about space as a career?
Well, I think it's a very important time to be thinking about a career in space because the people who are alive and on this planet today, we are the generation that's going to develop a multi-planetary human species. So the kids these days who are in grade school, they're going to grow up in a workforce where we have ongoing in space operations, not just in orbit but on the moon. And, right now I work with so many lunar hardware companies and, space agencies all over the world. And the engineers that end up working on the lunar hardware are often aerospace or mechanical engineers, and they didn't learn anything about the moon throughout their curriculum. So they're kind of learning about the moon for the first time. I mean,
Hmm.
it's not too uncommon for these engineers to reach out to me and they're surprised that the moon is dusty.
Ha!
So what we really need to do is we need to start training our younger workforce of what are these planets actually like, because we're getting ready to live there. And
Yep.
if we want our technology to succeed, we really have to be prepared for those environments. And it's different than Earth, and there's a lot of things we take for granted here. But so I think this is a really important time for young people to get excited about a future in space as well. I think, a lot of our parents, this is so different than what we're used to, especially since, we took so long to kind of start making our way back to the moon. So I think we kind of forgot that there's actually been a lot happening. And, one of
Yep.
my favorite aspects about my job is I get to be on the crux of the technology that's being developed. We're working with 5,000 different clients globally, solving problems like 3D printing in space, making solar panels out of lunar materials, making ceramics and building bricks out of lunar and Martian regolith. And even melting it and extracting volatiles from it and extracting metals from it. So these are problems we're already solving, if not have
Hmm.
already solved to completion. And we're just waiting on the transport over there. So we're way closer to realizing this reality than people think. It's just not what you hear on the news. So
No. Well,
it's
I
going to
don't.
come up on us really fast, which is,
Yeah, I certainly believe that, and the optimism I think is well placed. Um,
mhm,
I remember I read the Foundation Asimov's Foundation series when I was 10 or 11.
mhm,
Never forget that, and it was so perfectly well thought out for a range of reasons. Um, but last question, and
yeah,
my question will be loaded.
yeah.
No one needs to assume that your answer is thereby loaded. And my question is this: what do you say to the knucklehead chatterbrains who believe we never landed on the moon and that space doesn't exist, and that there's actually a firmament like a medieval concept of a shell around the Earth on which the stars are painted. Do you have any words for them that are perhaps less loaded than mine?
Well, there's a couple things. One, I will say, boy, do I have this conversation all the time. The thing, and I think a lot of people try to credit me with faking the moon landings.
That was you?
It's
Wow.
this is a really
It's inappropriate, but you look phenomenal for being what, 75 or whatever it is. That's great. Do tell. That sounds awesome. Tell me how that conversation went.
Well, it's always a fun conversation, but what I will say is, believe what you will. I'm not here to try to change what you want to believe, but it must be so small to live in a reality where you don't believe that humans have the capability to get to our own moon. Because, when
Well
we
put.
kind of, have this mindset around rocket science, it's so hard, and all of these problems are so hard. But I'm here to tell you that us humans are actually really bright, and we know how to do this kind of shit. And if you want to live your life believing that we can't, that's fine, but that just must be so small. That must be so limiting to live in a world like that. Because in
Hmm.
reality, we're going places. We literally live in orbit and we're about to live on the moon. So
That's
whether
great.
you
That
want to
is
believe in that or not,
so
we're
much
moving
more
on.
nicely put than I could ever have thought. I'd never heard this nonsense, right? So I made it all the way into my early 20s without ever
Yeah,
hearing this stupidity about
yeah,
we never
yeah,
landed on the moon.
yeah.
And I heard about it because we were in Australia. I went to business school in Sydney, and we had 30 months to kill before classes started. Drove out to the outback,
Hmm.
and there's an observatory out there um, that I think was funded by the CIA in part. But anyway, it's an astronomy outpost in the outback of Australia because there's no light pollution in the southern hemisphere, and we're sitting there as one of the astronomers at the facility is giving a talk to all the tourists, the guests, or they were doing
Right.
much like NASA. You come tour Kennedy Space Center, and he's talking about our trip to the moon, and there are about 50 people in the room, mostly Brits and Aussies. We were the only Americans. There were a few Canadians, so I'll get to in a second about Canadians in Australia, which is kind of funny. Um, uh, and the presenter says, "Who here believes the moon landing was faked?" Now, I'd never even heard this question before. Never mind, 40% of the room shot their hands up.
Yeah.
And I was like, I'm looking around, like, I don't know if you ever found yourself suddenly you're in the midst of a dangerous cult and you wonder, can you get up quietly and get to the door without startling them? Um, and that was bizarre enough. But then he said, I'm going to give you three or four reasons why that's insane. One of them was the best, which was really good, was the astronauts placed a set of mirrored prisms on the lunar surface that we then bounce infrared, laser shots off of, and that gives you an absolute like to the inch distance between the Earth and Moon. So like there is evidence of human habitation on the Moon. In fact, that exists. Right? So it was interesting, but it was just one of the weirdest things that I've ever heard. And now that I'm doing this after being in terrestrial mining for years, I
Hmm.
had. And I hope they see this and they get to understand that I wish them the best. They have help. I was telling this old colleague that I've done work with before, smart person.
Hmm.
Uh, and that's when he said to me, "Oh, so you believe the moon exists? Not only did we fake it, but the moon doesn't exist." I was like, "I'm sorry, I really what? Like, say that again. We have got a bad connection. What?"
Yeah.
And he goes on and on. He's been learning from TikTok that, in fact, the firmament, the medieval Ptolemaic idea of a hard candy coated shell surrounding the Earth, that's what's up there. He's like, well, if you look at the moon, if it rotates, why does it always show us the same face? So now, like, I'm dusting off my Keplerian geometry, right? And
Yeah.
trying to talk to him about, the orbital plane. And oh my God. it was just insanity. But I would like to thank you for giving me sort of the kindest, softest rebuttal to that idiocy that I have ever heard. That
Well,
it's more of a I'm so sorry for you. That
right, because it's like if that's the world you're choosing to live in, I'm not here to change your mind, but
no,
I'm gonna keep living my life, and a lot of amazing things are gonna keep happening, whether you're on board or not.
right.
So
All right.
yeah.
Well, with that insanely optimistic view of apparently 40% of our fellow Americans. Anyway, I did have to say this. My Canadian friends always hate this. But when you're in Australia,
Mhm.
and anyone, a restaurant, wherever, hears your accent, they will say to you, "Oh, are you Canadian?" And the reason is, I was like, why do you keep asking? I'm an American. Like, statistically, it's more likely, first off, that I am American, right? And they said, we learned from painful experience. If you say to an American, are you Canadian? They say, no, I'm American. If you say to a Canadian, are you American? You get a 9-hour lecture on how Canada isn't America. Great. I said, so it's kind of like New Zealand, Australia. Like, oh, don't even get me started. But anyway, this occurred to me. Nothing to do with space whatsoever. But, those sorts of small ethnocultural boundary issues I anticipate are going to be as prevalent on the moon as anywhere else. Are you from the moon? No, I'm from Mars. Okay, sorry.
Oops.
I'd have a weird gait if I was okay. Fine, sorry, whatever. You walk like a Martian. Anyway, so Anna, thank you very much for your time. I know I've asked you for final words. This time I actually mean it. Final thought for anyone, or have you dispensed all your wisdom for today?
Well, let's do big things. We have a really exciting future ahead of us. I definitely suggest everyone get on board, get involved. If you don't want to work in the space industry, then just start watching space news. Get involved. There's much more happening in space than just the rocket launches. We're building some really awesome technology. We're landing rovers on the moon. Last year we landed on the moon several times, and a lot of people don't even know that. So get involved, find out what's going on, and especially if you have young kids, get them involved in space as well.
Awesome. Well, thank you so much. And for my regular listeners, you know by now that the smartest thing for you to do is to turn off the mainstream media who are lying to you 24/7 and tune into Messy Times. Thanks so much.